left, so I'm going to go over at least the adding and subtracting, and then we'll hit it again next week, okay?
Okay.
So, the second page of your notes, we've got adding and subtracting. Same rules for regular fractions, right? So, when we have fractions, we can either have fractions with a like denominator, or we can have fractions with an unlike denominator. If we have fractions with a like denominator, we simply perform the order of operation on the top values, and we keep the denominator the same. If we have fractions with an unlike denominator, we first have to make a common denominator and then perform the operation on the top. Okay? So let's look at like denominators now that we have monomials things on it. Okay? So when our denominator is the same and we are adding and subtracting, the rule always says if they're the same, they just stay the same. So it goes straight across. Now, we are performing this action only to the top guys. We are not adding the bottoms also. This doesn't become 8a squared.
Right.
It just stays the same. And so now on the top, we're going to combine all like terms. So 13a and 5a, can we combine that together? Yeah, that becomes
18a.
18a. Easy breezy. All right? So what about this one? Our denominator is more complicated.
It's still the same though. So.
But it is still exactly the same. So since it's exactly the same, we keep it exactly the same. Correct? And then we are performing our action to the entire top, and we're going to combine like terms. So what do we have on the top now?
Y squared plus 10y plus 21.
Okay. Now, is this fully simplified?
No.
Now we're back to our simplifying rules that we just used before. We have a trinomial on the top where we ask ourselves what factors of 21 add up to be 10. That's going to be 3 and 7. So I have, and they're both the same and they're both positive. Okay. And our bottom, this is a difference of squares. So 9 I'm going to rewrite as 3 squared. That means I have 2 identical ones, but one is positive and one is negative. Now I can cancel my like term, my like binomials, and I'm left with y plus 7
over y minus 3.
Over y minus 3. Okay. So sometimes when we add and subtract them, then it gives us something else that can now be simplified. Okay? Because these could not be simplified on their own, but they could be simplified once they were combined. Okay? Now, what about if it has an unlike denominator? Okay? If it has an unlike denominator, we have to use the same rules as we did with regular fractions. If I have 1/2 plus 1/3, we cannot combine these because they don't have the common denominator. So our common denominator, we're looking for that least common multiple of them, least common denominator. In this case, it would be
6.
6. So I'm going to turn this one into a fraction with a 6 on the bottom, and this one into a fraction with a 6 on the bottom, which means I have multiplied this entire first fraction
by 3.
By 3 over 3, right? The number 1. And this fraction by
2 over 2.
2 over 2. So now I have 3 over 6 plus 2 over 6. Now I can add them, correct?
Yeah.
So I add the tops.
5, 6.
And I keep the bottom the same. Okay? So the same thing applies with our binomials. Let's look at this guy. We're going to show one. And then we're going to hit this again next week, okay?
Okay.
And I'll look at your homework and figure out what to adjust. So on this first one, we have 2 different binomials. So we could think of this as like a 3 and that as a 6. Sorry, I'm going to go back to this one. We have 2x and 3x. They both have x's, but they're not the same because this is a 2 and this is a 3. So this denominator needs a 3 and this fraction needs a 2. So I would multiply my whole first fraction by 3/3, my whole second fraction by 2/2, and have 45/6x minus 32/6x, right?
Right.
So the bottom stays the same. I perform the action on the top guys. 45 minus 32, 8 and 5 is 13. And we just have 13/6x. Now, once I divided this, if these two values had something else that they could simplify out, like if this was 12/6, we would go ahead and reduce it further. Okay?
Well, if it was 12, would it just be,
If it ended up 12/6,
it would just be x, or 2/x, right?
2/x, perfect.
Okay.
All right? So, we know how to simplify, multiply, and divide binomials, fractions, for rationals, and how to add them with like values, with like bases. So, what I want you to do, and I will update this on our homework stuff, is I want you to, part of the work is doing the notes, completing the examples for the notes.
Okay.
Because on the notes, I have done basically fill in the blanks.
Okay.
So as you're working through, you're just filling in the spots, and this will help you think through what else can I do? Because, okay, Miss Thomas put an extra thing there. That means I need to be able to reduce it even further on that, okay?
Okay.
So work through the notes on the front and the back of the first one, and these guys with like bases.
Okay.
Then do these bottom two with unlike bases, and then we will hit the rest of this next week.
Okay.
All right?
Here, I'll just go ahead and mark.
And then I
them.
will update. Yeah, so
So-
we're gonna keep it
Do these, all these.
Yeah. on yours.
Okay.
You wanna do it on yours?
Oh yeah. Yeah. Sorry.
That's fine.
Do,
Okay.
do these ones,
Uh-huh.
and then do.
And then this whole page.
Okay.
Okay. And then the rest of it we'll tackle next week.
Okay.
All right? And then I will adjust which homework pages that you pull out of there too.
Okay.
I'll get
If there's any extra ones that you send, like over email that you need done, you might want to text me too, because I have problems with my email
Okay.
because it gets full really
Okay.
fast. So I'll, like, my iCloud storage